Okay, so it's now time to do a quick demo on the deep learning methodology that we have learned so far, right? And for that, as I explained to you, there's a website Kaggle. If you go to Kaggle, there is a PIMA Indians diabetes database. Now, who were PIMA Indians, right? So PIMA Indians were a group of Native Americans living in an area consisting of what is now the central or southern Arizona, right? So what they've done is they have actually created a database, and it is a diabetes database. Now, if I quickly read about it, so this data set originated from the National Institute of Diabetes and Digestive and Kidney Diseases. The objective of the dataset is to diagnostically predict whether or not a patient has diabetes, right? So what it will do is you'll see that it will have several features, right? Or you can say several metrics that are given for a lot of other patients. And based on those metrics, it has to decide whether the patient has diabetes or not, right? So several constraints were placed in the selection of these instances from a larger database. Another important key thing about this is all patients here are females and at least 21 years old of the PIMA Indian heritage, right? It's a specific area, and all the patients are females and over the age of say 21 years, right? Now, one way is either you can download the data from here, or you can actually get it from the resources section. So if I actually show you from the resources section, this is how it looks like. Like these are the different values, and what these values mean, I'll show you. But the last column is quite important because 1 and zeros, which shows whether a person has diabetes or the person doesn't have diabetes, right? So what do these columns indicate? These columns actually indicate, the first one is number of times a person is pregnant, right? The number of pregnancies. The plasma glucose concentration. The third one is blood pressure, right? The next one is skin thickness, the triceps skin fold thickness. Then it looks at the insulin levels. Then it looks at the BMI, which is the body mass index. Then it looks at the diabetes pedigree function. It looks at the age of the person, right? All these are ages. And then it gives you the outcome 0 or 1, right? So that's quite important, right? So what we'll do is we will now use a machine learning model. So we'll create our own deep learning model based on neural networks, and we will try and use this diabetes database, right? So what I've done is, as I always say, best is you go along with me, so you can actually work on this. And what we'll do is we just simply go to our Anaconda. We'll launch a Jupyter notebook, right? A new notebook gets launched. Right here you can say new Python, right? So you've got a new Python kernel. Before I go ahead, I just want to give you two terms, very important terms. One is the Keras and other is the TensorFlow. So Keras is an open source library that provides a Python interface for artificial neural networks, and Keras acts as an interface for the TensorFlow library. But now you might ask, but what is TensorFlow? TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural networks. That's why in this demo, we will make use of Keras and TensorFlow. So the best way is, first what we need to do is we need to simply import our Python libraries, right? So we just simply import these libraries. So you just simply copy and you just simply paste into your, say the Jupyter notebook that we have opened, right? So I just simply paste, I run, right? All good. Then I do next. Then we need to load the data set, right? So it's the same data set that I showed you, this one, right? So we are simply loading this data set. All we are doing is we are actually giving the exact path. So here I've just given like my path in my MacBook, but if you have your own path, you can just change it, right? And we are saying it's delimited by commas. As you can see, various values are separated by commas. So we load this data set. Right. The next one is we split into the x-axis and y-axis. Very important. Which is the input x and the output is y. So output is where it says whether a person has diabetes, yes or no. Right. So again, you go here, you execute it, and quite important here is x-axis is from 0 to 7. Right. So from here it is up to this point, and y is the last bit, which is the last column, right? So y is the 8th one. Good. Then what we do is we define the Keras model. So as I explained you, what is Keras? Keras is nothing but the open source library that provides Python interface. So now we define the Keras model. So you just simply go there and execute it, right? You can run it, and then we compile the model, right? So we are saying it optimizer is Adam, the matrix is accuracy, right? You just simply compile the model. Okay, we've compiled the model. Then comes training the Keras model. So it's very important that you need to train the model, right? So the command for training the model is model.fit. You give the X, you give the Y, and you give the batch size, right? So let's say we train the model, right? Now your training is done. Very good. Now you need to evaluate the accuracy of the model. Let's see how accurate our model is, right? So if I execute this statement, it says, hey, it's around 77% accurate. What if we try to train the model again? Does the accuracy improve? Let's see. So I train it again. I again check the accuracy, and let's see what it says. So yes, slight improvement from 77.21, it's improved to 77.34, not bad. So it means that that's where we say that the quality of the data and the quantity of data is really important. If your data is quite large and your quality is good, then obviously your accuracy would be much better, right? Now you make some class predictions with the model. So now we are going to make some kind of predictions. Let's say what it does. So we run it, right? So it has executed. And now is the time to summarize the first test cases, right? So now we are looking to look at the first 50 test cases and see the results, right? So what we will do is we will execute it, and you'll see that whether it gives you the expected value or not. So in this case, our machine learning algorithm says that yes, this person is supposed to have diabetes, right? And expected was 1, which is good. In the next one, the expected is 0 and we got a 0, right? In the third one, say here we have 1 and a 1, good. So 0 and a 0, 1 and 1. There would be certain places where it might fail. So 0, 0, 0, say. See this case. Here, in this case, it is saying that our model predicts that the person doesn't have diabetes, but expected is 1. So this is where it's bit of the model is failing. So it's just because we've trained it on say a very small amount of data. So that's why if you have a lot of data, then obviously your accuracy and your model will improve over time. So I think now you got a good understanding. As I always say, that you are trying to look at the patterns, and based on the patterns you are making the predictions, and that's all we are doing. So previously you saw this in a more theoretical manner, but I think with this video you've got a very, very good understanding how it works practically using Python libraries, using Keras, using TensorFlow, how it all works, right? So I hope you enjoyed it. Thanks for watching.